All right, we gotta have a talk. I really hope my other math teachers don't hear me. But here's the deal. You may have been told to memorize the unit circle in the past for trigonometry, and you know what? We don't want you to do that. Why? Because we want you to be able to find any radian measure at any time. All right, now I know that you might think, hey, the unit circle is just all these pies around the circle, right? It's all these pies around the circle. It's not that at all. They just put the pie out there because it would get all messed up if we put the measure in there. Don't forget that first video that we need you to understand for this one is a radian is an angle. What? It is. It can be measured in degrees or radians, angles that is. They can be measured in degrees or radians. So we're going to talk about radian measures on a unit circle today and how you don't have to memorize. You can just think about, and it's going to be, think about fractional parts, and it's going to be one of the best things for this whole chapter. Can't wait. Let's go. Okay, so here's the thing about the unit circle. Ready? First of all, if it's truly a unit circle, that means the radius of the circle is 1. Oftentimes, we'll use the measures of the radians when it's not even a unit circle, but we'll talk about that later. So first of all, this is the initial side of the angle. If it's also the terminal side of the angle, that means it didn't go anywhere. So it would make sense that that is 0 radians, right? The angle is 0, whether it's degrees or radians, same thing. And here's another thing you need to understand is if the terminal side is over here, most of you will probably remember that that is pi radians, okay? Now, why is that pi radians? Once again, it doesn't matter what the radius of the circle is. You're going to take that arc, remember that arc right there, and you're going to divide by the radius. Well, if you take pi r, because isn't 2 pi r, actually, let's just go to that. 2 pi r over r, that would be the entire circumference of the circle divided by the radius. That would be 2 pi to here. So obviously, if we take pi r divided by r, which would be this arc divided by the radius, you would get pi. Long story short, we're going to use that concept of you knowing that 180 degrees there, that angle is pi. And here's how. Now, yes, you could memorize angles, but we're going to start with some very simple 45-degree angles. If you agree that this is 180, then you would agree that coming straight out here and then straight out here would break this into 1, 2, 3, 4 angles. We're not going to argue there. And they're all 45 degrees. 90-degree angle split in two, 45 degrees. So here's the deal. It's all about fractional parts of pi. So would you agree that this is 1, 2, 3, 4 pi over 4, right? Which reduces to pi. Well, if this is just 1/4 of pi, it's literally pi over 4, 1/4 of pi. And then if you have 2 of those, oh, well, that's 2/4 of pi, which is simply pi over 2. Now, before actually, let's do one more. So obviously this is 3 pi over 4, which is the same thing as 3/4 pi. Now, again, why did I write them out there? Because if I write them in here, it'll be all messed up and we won't be able to see anything. But notice, this pi over 4 is not a point out here. Okay, it's not a point out here. It's not anywhere out there. It's this angle. Okay, so that angle is 45 degrees. It's definitely 45 degrees, but it's also pi over 4. All right, those are the same thing. One's in radians, one's in degrees. Now we can keep going with this all the way around the circle. If we went out to this one, down here, and down here, all the way around the circle, we would be at 4 pi over 4, right? 6 pi, I'm sorry, I skipped one. 5 pi over 4, right? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2. And then we could have 7 pi over 4. And then guess what? We get right back to 8 pi over 4, which reduces to 2 pi. So look at how many we got just from knowing, breaking it up into 45-degree angles or sections of 4, each pi into sections of 4. All right, so we're going to talk about even more. So what if we weren't talking about 45-degree angles? Well, 30-degree angles and 60-degree angles come up a lot in trigonometry, the special right angles. So let's talk about 30-degree angles. if I had a 30-degree angle here and then another 30-degree angle, 30 degree, 30 degree, 30 degree, 30, 60, 90, right? 120, 150, 180. All right, we could keep doing that. We could split each quadrant here into 3 equal sections. You can see those aren't perfect. But what would this first one be? It all comes off of this being pi, right? So this first one here would be 1, 2, 3, 4, 5, 6, 1/6 of the way to pi. 1/6 of the way to pi. And then 2/6 of the way to pi, which reduces to pi over 3. 3/6 of the way to pi, 3 pi over 6. 4/6 of the way to pi, and I'm just reducing those fractions. 5/6 of pi, 6/6 of pi, 7/6 of pi, 8/6 of pi, 9/6 of pi, 10/6 of pi, and then 11 pi over 6 back to, we knew it started at 0, I didn't write it, but now we're back to 2 pi again. So here's the deal. I mean, look at all of those radian measures I can get, and I can understand just by knowing what the fractional part of the circle is. All right. So we're going to try. Here's the thing we don't need. We don't need you to write all of these on one diagram, memorize it, and then get to that spot. We want you to think about it, because do you see how this is pi over 4 right here? Well, we need you to be able to get to negative pi over 4. So that means, oh, we just go in the other direction. And a lot of times that's lost when you just memorize that unit circle. So here's the deal. I'm going to say, hey, what if we were just doing a problem? All right. And the problem asked for me to get to, 5 pi over 4. And I didn't know where that was. And I'm like, all right, you don't have to write all of them out. You have to think to yourselves, I'm 5/4 of the way to pi. Well, once again, there'd be like, 1/4 of the way, 2 quarters, 3 quarters, 4 quarters. And here I am, 5/4 of the way to pi. And then we're going to be writing these little reference angles right here. And then that's it. Like, this is 5 pi over 4, because it would be this angle with the reference angle of theta right there. So we want you to be able to find and locate these radian measures without having to draw all of them out at one time. Okay, hope that helped. It will continue to be a journey, but I know that if you watch that video again, if you need to, the fractional parts will help. Here's the deal. I don't even think a part of it will help you. I think the whole circle will help you. Hey, maybe it'll raise your grade 1 unit. Circle. Okay, I'm done. Bye.